Hello, students. How are you? I am fine. I am your course coordinator, Daniel Ahmed Khan. And today in chemistry, we're going to discuss about the first law of thermodynamics. So, have you ever seen that whenever we pass some amount of energy to the system may be anything which is boiling or the water which needs to boil. Okay, so when we provide certain amount of heat, the provided heat enables the molecules of the water to get energized. Okay, so when the molecule get energized, they started to push one another into the container, and when their internal energy increased up to certain extent, then they start to apply force, apply pressure on the wall of the container. Okay, so when there is a certain amount of energy, when they have some certain amount of energy, they try to apply these all forces on the container and on the piston. Okay, so in this case, when they get enough amount of energy, they start pushing piston and the piston starts moving up slightly and the piston reaches here. So at previously, the volume of the container was V1 because the piston was at that point, and now the volume becomes V2 because the piston is at the position which has now been changed. Okay, so in this scenario we see that the energy we supplied, which is equals to Q, it helps the molecules to get energized first. It means that the supplied heat is utilized first in increasing the internal energy, and then it moved the piston up at some height and the volume gets changed. So it means that there is some work done happened. Okay, so it means that the supplied heat is utilized in internal energy and then it is helpful in some work. So this is basically our first law of thermodynamics. The energy supplied is equals to the internal energy plus work done. Okay, so this is the basic of first law of thermodynamics, that all the supplied heat gonna convert into internal energy and work. So let's say we have a numerical. Consider a system in which 500 joules is supplied to the system. Applied to the system, which helps in increasing the internal energy to 250 joules. What will be the work done? Okay, so here we're gonna find the work done. Now we can find easily by first we will find data, and in data we can write the given things like heat supplied is 500 joules and the internal energy is 250 joules and the work done we're gonna find. So it is easy to find. Okay, work done, the formula is Q is equals to delta U plus W, and Q minus delta U is equals to W, And how we gonna find Q is 500 and this is minus 250. This will tell us the work done. So the work done is 250 joules. I hope this numerical helps you in clearing up your first law of thermodynamics confusion. In next class, we will discuss something more experienced. Okay, thank you.